Hello everyone, today I'm going to talk about the Falcon 9 Block 5 and what actually makes it different from the earlier versions. First of all, yes, this is another video about current spaceflight events since the first Falcon 9 Block 5 is scheduled to launch this evening, carrying a communications satellite and scheduled to land on a drone ship. I do still have videos coming about more theoretical questions, interesting physics questions, common online misconceptions, and a few more theoretical spaceflight concepts, but I'm currently a bit busy with what's basically startup founding paperwork and some research and university, and so I'm not really getting to make these explanation videos as frequently as I might like to. Now, these interesting spaceflight events like the InSight launch or the Falcon 9 Block 5 launch are following one after another, and with the limited frequency at which I can make these videos, I'm basically preoccupied keeping up with these events. So here's hoping that spaceflight might calm down a little bit over the next month so I can get around to these more theoretical videos I'm really hoping to make, because I've always found understanding the physics or mathematics behind some concept or problem or question a lot more interesting than reading down fun facts about some event, although this is still incredibly interesting because it's still a new Falcon 9 version. So with that, let's move to the actual list of changes that has been done compared to the earlier Falcon 9 versions, at least the most notable and interesting ones, because generally this is a large kind of wrap-up update. The bulk volume of changes between the Block 5 and earlier Falcon 9s is a lot of tiny details that have been improved after experience, mostly to just make the operation more practical, faster, and cheaper, and make reuse more rapid. The most visible change is, of course, the paint scheme, which isn't really that interesting in and of itself. They placed the SpaceX writing slightly differently. The interstage is no longer painted and is black since it's made of carbon fiber, which itself isn't actually a change. This has been the case for all Falcon 9 rockets, but it's now more visible since it's no longer painted. The paint itself is quite interesting because it has been changed from the basic aircraft or spacecraft paint that they've used before, which was fine for ascent but started to basically melt off during the re-entry, with a more heat-resistant paint that not only survives the re-entry itself but also helps to protect the booster, together with a new insulation which protects the core from a thermal stress and a thermal wear and tear. It's not actually that heat resistant, so it doesn't really allow for any much harsher re-entries, but it does allow for the same type of re-entry with much less refurbishment needed. For the eventual reuse, the actual goal of the Block 5 design is to reuse the rocket mostly without any refurbishment. They want to go up to 10 launches without refurbishment, just inspections. Of course, if they find anything on these inspections, they would refurbish that, but the expected goal is that they would only find anything roughly every 10 missions or so, so they could go 10 flights without actually having to replace anything, which makes everything a lot cheaper. SpaceX is, however, actually a lot more ambitious than often reported, because often people just take these 10 flights and quote them and that's it. But those are the flights before any maintenance has to be done. The actual number of flights is at least speculated up to 100 flights per booster. Another really significant change that reduces the damage and thus maintenance needed on the rocket and thus helps reusability is a new thermal protection system for the engines themselves, which are kind of at the back end and get most of the heat during the re-entry. Now, so far, the engines themselves have basically worked as a heat shield. There were some measures in place to protect some of the more sensitive parts. The nozzles, of course, will be exposed. They have to be because they do the landing burn, and they have to be heat resistant anyways, but behind the nozzles, basically at the neck, there will now be a heat shield between the engines that protects the upper parts of the engines properly, the combustion chamber and the plumbing and the valves, and basically just has holes in it for the neck of the nozzles, which then reach through it. This is going to vastly improve the service lifetime of most of the engine parts and thus reduce the needed maintenance and replacements and make it possible to fly so many times. Another update that is going to help with rapid reusability will be retractable landing legs. Now this fall, the Falcon 9 basically had landing legs that could extend on their own by the vehicle, but once extended they basically had to be packed up again from the outside, which adds to the work of recovering and transporting and refurbishing the rocket for another launch, especially when you keep in mind that this is all bigger than it looks and these tiny landing legs are actually quite huge. Now the vehicle can retract these landing legs itself, so basically once you lift the Falcon 9 Block 5 up with a crane, you basically press a button and the landing legs retract, and then you can pack it on a transporter and drive it back into your hangar for inspection. Not all, but quite a lot of the smaller changes are similar to this, basic practicality changes that make the workload of recovering and packing up and transporting and inspecting and refurbishing and relaunching the rocket just a lot easier in terms of logistics. However, a few changes have also been made to actually improve the performance and efficiency of the Block 5 Falcon 9. Although these aren't all actually mechanical changes on the rocket itself, some of them are mostly software based. The engines have been uprated, but that basically means they're still the same engines, they just have been tested at a higher throttle, so they're safely allowed to provide more thrust. The engines have actually only been modified very little. This is mostly a thing of collecting data, testing engines, and changing the flight software to, well, throttle up your engines even more. And of course, given basic rocket launch profile optimization and gravity losses, more thrust means a slightly more fuel-efficient launch and the ability to launch slightly bigger payloads. Another flight software update allows the rocket to land more efficiently. Essentially, the Falcon 9 already uses aerodynamics for landing. It doesn't have wings, but its cylinder still works as a very rudimentary lifting body, which does help control the rocket while landing, basically keeping it on path during its descent. And this can be used to somewhat slow the rocket down too. Essentially, if instead of following your straight or gravity curved path to your landing pad, instead you swerve back and forth, you can slow down the rocket aerodynamically even more than now before actually landing, and thus save fuel on the actual landing burn. This means that less fuel has to be reserved for the landing, and larger payloads can be launched with a reusable Falcon 9. The last really big and notable change would be the grid fins, although technically I wouldn't necessarily call that a Block 5 update, but the Block 5 Falcon 9 will regularly and by default use the new titanium grid fins, which had been test flown on a few Falcon 9 boosters before, as well as the side boosters of the first Falcon Heavy test flight. Now, I've talked about the thermal advantage of the titanium grid fins before. Another advantage of these titanium grid fins is that titanium is just stronger than aluminum. It's also a bit heavier, and relative to its strength, it's actually the same weight, or relative to its weight, it's the same strength. But since it's heavier and stronger, the grid fins can be made thinner, and well, the entire geometry of the grid fins has actually changed. They are larger and they provide more control, which also helps with the new landing path profile, where the rocket slows down more aerodynamically and saves fuel. They are also, just like the rest of the rocket, much more thermally resilient and thus easier to reuse many times. So these are all the major upgrades on the Block 5 Falcon 9. The rest are all tiny little engineering details. The Block 5 is supposed to be the last major update of the Falcon 9. There have been a few purely hypothetical suggestions for major changes to the Falcon 9 later, and with fairing reusability and some other details we might still see some changes, but in terms of major rocket development, SpaceX seems to be focusing on the BFR now. Also in 2018 the Falcon Heavy is of course scheduled to actually do a few useful satellite missions after its test flight earlier this year, and while we won't see any really major updates there either, and it is basically based on the Falcon 9, I mean it uses Falcon 9 cores and now Falcon 9 Block 5 cores, the side boosters slightly and the center core heavily modified, we might still see some changes and updates on the details of that connection and setup. Though most excitingly, there are actually plans to launch astronauts on a Falcon 9 Block 5 rocket, basically picking up the ISS crew transport missions for NASA, splitting those between Roscosmos and SpaceX. Now, there might of course be some further pushbacks, but the aspect that at least there's a scheduled astronaut launch now within reach, and the version of the Falcon 9 that is going to launch astronauts is going to be flown today is pretty exciting. Although even with the Falcon 9's previous track record and theoretical safety analysis, it will take a few flights of this specific Falcon 9 version to gain the track record necessary to apply for human rating. Now this is usually some 7 or 8 flights, although there are some variations on this. It's very reasonable to test fly the exact rocket type that is going to launch astronauts this often before actually putting a human on top. But with SpaceX launch frequency, that is actually very achievable within this year. Although of course any minor malfunctions might cause safety concerns and further reviews and push back the human carrying launch further. But let's hope for the best and watch a new slightly modified rocket type launch today. If you have any questions about spaceflight or the physics and mathematics behind it, I'm always open for requests, and as always, thanks for watching.